Hi there, I'm Mr. Orr, and I'm back to talk with you about section 6.2 in your algebra books, and that is the substitution method of solving two equations simultaneously. So what we have is two linear equations, and we are asked to find the point of intersection. That is the solution for those two lines. So let's write down a couple of lines here. Notice we've dispensed with the graph now because we're not going to be solving by graphing. We're going to be solving algebraically. So we have y equals 2x plus 1, and the other one is 3x plus y equals negative 9. Let me write that over here. I want to make sure I don't go off the screen. 3x plus y equals negative 9. All right, now, substitution method says set one of the equations equal to one of the variables and then substitute the amount that it's, I'm not saying that in a way that's going to be clear. Let me try that again. Set one of the equations equal to one of the variables. We have that. It's already done for us. Y is equal to 2x plus 1, so y, one variable, is on one side. That's what I want. Now, if y is equal to 2x plus 1, then I can take that value 2x plus 1 and put it in here in place of y. 2x plus 1 is equal to y, so I replace y with 2x plus 1. So now I get 3x plus, instead of y, I write 2x plus 1 equals negative 9. All right? Now notice, I have only one variable in this equation, so I can solve for x. So I have 3x plus 2x plus 1 equals negative 9. So that gives me 5x plus 1. 5, let me write a better 5 here. Let me write it over here. 5x plus 1 equals negative 9. So I subtract 1, and I get 5x equals negative 10. I divide by 5, and I get x equals negative 2. All right? Now I know the x value of the point of intersection. Now I have to find the y value of the point of intersection. So let's take that value for x and put it back into one of the original equations. If I put negative 2 in here for x, I get negative 2 times 2 is negative 4, plus 1 is negative 3. So I get a y equals negative 3. Now, that's the point of intersection. Now, if we did it right, I could take either of these two original equations, and that was this one or this one. And I could put this point in and it would work in both of them. It is the only point that will work in both of them because it's the only place where they intersect. So let's try it. Negative 2 times 2 is negative 4, plus 1 is negative 3. So I got negative 3 equals y, so that's correct. Let's try it in this one. I get x is negative 2, that's negative 6, plus negative 3 is negative 9. So it worked in both equations. So that, in fact, is the solution, and I would normally write it as a point, negative 2, comma, negative 3, in parentheses. That's an x and y coordinate of the point of intersection of the two lines. Now, I'd like to do one other one here. And with most of these, they will kind of be set up for you, but let me show you one that's not. That would be the best way to go next. 5x minus y equals 5. That's one of my equations. So 5x minus y equals 5. And the other one is negative x plus 3y equals 13. 3y equals 13. Neither one of these is set up in such a way that it's equal to one of the variables. So what I may have to do is a little rearranging. Now I have choices here. I can either get this one equal to x or y, or this one equal to x or y. I don't want to set this one equal to x because I'm going to have to divide by 5 and then I'll get a fraction. I don't want fractions. This one I don't want to set equal to y because, again, I have to divide by 3 and I'll get fractions. So my choices are either set this one equal to y or this one equal to x, and it makes no difference. So let's just take the first one here. If I take that and subtract 5x, I get, I'm going to write it up here, don't know if you can see that for sure, let's write it over here. subtract 5x, and I get negative y equals negative 5x plus 5. Now, I divide or multiply by negative 1, and I get y equals 5x minus 5, all the signs reversed. Now I have what I want, because I know what y is equal to, so I can take that value and put it in place of y over here in this equation. So that's going to give me negative x plus 3 times 5x minus 5 is equal to 13. So I took this equation here, I substituted 5x minus 5 in place of y, and I got this. So this went in place of y. Okay? Now let's see if we can solve that. Negative x plus 15x minus 15 equals 13. All right? This is 15x minus x is 14x equals, now I add 15 to both sides and I get 28, which works out nicely, dividing by 14, x equals 2. Hopefully you can still see that. So if x equals 2, now I can take that and put it into one of my original equations, or in fact, I can put it in here. I rearrange this one, but it's still the original equation, it's just rearranged. So I take x equals 2, 2 times 5 is 10, minus 5, so y equals 5. So I have the point of intersection 2, 5. Now, let's make sure that works. So if I put those two into the original one over here, I get 10 minus 5 equals 5. Correct. Over here, if I put it into the original one, I get 2 times 5 is negative 10 plus 5 equals negative y, and y is 5, so it equals negative 5. So in fact, they both worked. This point is the point of intersection. And I believe that that is what you need to know for this section. So good luck, and the next time we will be looking at the elimination or combination method of solving linear equations. Different process, same end result, so you actually will have 3 ways of solving linear equations simultaneously. You will have the graphing method, the substitution method, and the elimination or combination method. But as I've said before, almost always we're going to be using one of the 2 algebraic methods, which is combination, which is substitution or combination/elimination. The graphing method is just not always that accurate. Thank you.